Assuming that voltage with respect to time can be modeled as voltage with respect to time equals initial voltage sine of omega t, where omega is probably the angular frequency, where initial voltage and angular frequency are constants. What is the average voltage from 0 to pi over omega? Okay. So we have some sort of function, sine, so I'm going to be like, this. And I'm going to say that pi over omega is right here. And so the idea of what we're doing here is we want to take this area here. You get the idea? And I need another color. Ooh, orange. Make it into a rectangle where this is b minus a is this distance here, but since we're starting at 0 and going to pi over omega, it'd just be pi over omega minus 0, which would be pi over omega. And what we're looking for is this height right here. The formula for this is 1 over b minus a integral f of x dx, where this x is actually going to be t, and that f is going to be v. So v of t. Okay, one last part. dt. So we're going to do, I'm going to start by finding the area. This orange is just too assertive. Too assertive for me. I like it, but still it's a little much. A little distracting. So v naught sine omega t, where everything here is a constant with the exception of t. We take the derivative. So I'm going to start by doing a substitution. I'm going to say u equals omega t. du equals omega dt. Therefore, du over omega equals dt. Most people could just do this in their head. For me, it's going to depend on how much time I have available. If I am crunched for time and I am running behind in life, if I'm, do the little calculations, find out how much time I have to solve a problem, I am behind the curve, then I'll just kind of wing it and I'll be like, yeah, I'll probably just divide by omega. But if I have more time, I kind of like to go through and do this substitution in a more formal manner. That way I can see what I'm doing and I make fewer mistakes. The pink ones do not work well under pressure. Omega t. Oh, no. Okay. So omega t is u, sine of u, du over omega. Okay? And this would then be v naught over omega cosine of u. So the integral of sine goes to, so if we take the derivative from sine to cosine, it keeps the sign. But if we do the integral, it goes the opposite. So this will be negative cosine. The way to figure this out then would be if we took the derivative of cosine, we should get the opposite sign, so that would be true. Long story short, lots of words. Integral sine of x dx goes to negative cosine x. And you can just memorize that. What I do is I memorize that derivative of sine of x, derivative of x, goes to the same sign of cosine of x. Then I remember that the integral is the opposite. So much information. You guys probably don't have a problem with that. I do. And so I want to, if there's someone else out there that has difficulty with those small nuances in life, I want you to kind of, have one more trick to throw in your bag. Or not, if your call. Okay, focus. Negative v naught over w cosine u. Okay, which will be negative v naught over omega cosine of omega t. Yep, going back to omegas. And we're going to evaluate this from, 0 to pi over omega. 0 to pi over omega. Okay? I'm going to highlight this, move it back towards my board so I can maximize use of real estate. Go over to, light blue. So now we have negative V naught over omega, big bracket, cosine of, and I'm going to switch these. So now I'm going to do cosine of 0 minus cosine of omega times pi over omega. So what I did was if you switch the limits of integration, switch these two guys, you multiply by -1. It's not x -1, multiply by -1. Okay, and then we can simplify things here. So we have, it looks like it's not too bad. So cosine of 0 will be 1. Cosine of pi will be -1. But then we have a negative there, so we have a 2. So we have 2 V naught over omega. Ooh. Yes. So, okay, so take a quick step back here. So this right here is the area under the curve. So we want to be careful here because what we found then, so we're looking for the average. We're looking for the average here. So we found this green area here, the area under the curve, which is 2 V naught over omega. So we want to divide that by this distance here, which is pi over omega. So 2 V naught over omega divided by pi over omega. And this will give us, I know I kind of switched between omega and angular frequency. Omega is easier to say, so sometimes I switch back and forth. Okay, so when you divide by fractions, you multiply by their reciprocals. Cancel, cancel. 2 V naught over pi is the answer. And that will be our average value. Whoop. Green, 2 V naught over pi. Okay, so backtrack real quick. What we did, we had this equation. We're told to find the average value. Average value is you have area under the curve, you squish it into the shape of a rectangle, and you find the height of that rectangle. So you find the area under the curve first. This one was in depth enough with the area under the curve that you almost kind of sort of lose track that you're looking for not really the area under the curve, but for the average value. So the key part to keep in mind here is the answer is not the 2 V naught over omega, that guy. You have to divide by 1 over b minus a, which in this case, the b minus a is just pi over omega. So after you find the area of the curve, you divide by pi over omega. The omega cancels out and you're left with pi, which is always nice. I enjoy being left with some pi. So that's how I approach this problem. Average value. Be careful of the human performance trap of doing all this work, focusing on area under the curve, because that's the hard part. And then at the end, turning that in as your answer, when your answer should really be the average value, not the area under the curve. Thank you for stopping by. See you on the next problem.